Hello and Namaste everyone. In this video I am going to show how to find the integral using Simpson 1/3 rule and Simpson 3/8 rule. So let's start. First of all, we go to the editor. In the terminal, gedit Simpson 113.f90 end. We are going to find the value after integrating sin x using Simpson rule. This program finds the integral of sin x using Simpson's 1/3 rule. A equals to 0, B equals to pi/2, and n is equal to given by the user. So beginning with program Simpson 1/3 rule and implicit non-integer. For integer we have I and n, and similarly for real what we have is we have a, b, h, sum, f, x, and pi, and we have the function fx equals to sin of x. Now pi can be defined as pi is equal to 4 star 8 10 1.0. This is our pi. Print star comma enter the number of intervals. These intervals we can just write, and a is 0, b is equal to pi/2, h is equal to the difference b minus a, difference of interval, divided by n, and sum is given by f of a plus f of b. Now we use do loop. Do I is equal to 1 up to n minus 1. Then x is equal to a plus I star h. If we set a condition, if I by 2 star 2 not equal to I, then sum is equal to sum plus 4 star f of x, and else sum is equal to sum plus 2 star f of x, and if and do. We just close the if conditional and close the do loop. Then sum is equal to sum star h by 3.0. Print. Now to just print the answers, print star comma for n equals to n integral is equal to sum. Then we end the program, let's see, Simpson3. Simpson3. Now what we did is just we fixed the integers I and n real, a, b, h, sum, f, x and pi. F of x, the function is sin x. We just stated the value of pi. Now we ask the program to just enter the intervals. The value of a, b and h is the difference of b minus a divided by n, the sum. We just stated the sum as the functional value of a and functional value of b. Then we started with the do loop. Do loop goes from I to n minus 1, and x is initial value a plus the loop integer, and h is the size of intervals. Now what we did is here, if I by 2 star 2 means if the intervals are at even places, then sum is equal to the sum plus 4 times f of x. Else if the interval number is odd, then sum plus twice of x. Then and if the if conditional is ended, and we just end the do looping and the sum, the final sum is what it becomes is h by 3 times the sum f of a plus f of b 4 star f of x and 2 plus f of x, and just we print the results. For n is equal to the number of intervals is specified, and we just print the final results. Let's save it and just check out the answers, what it displays. The Fortran Simpson3.f90 So here is some errors. Let's correct the error. Oh, I missed the inverted comma over here. Let's recompile this. /a dot out. Let's enter the number of intervals 48, and at 48 intervals the integral value is given as 1. Format our results. Just remove this star, add brackets, and what we have is, first of all, we have a string, that is for n is equal to something. Then we have, what we have is some integer value, and for again we have a string. Let's add a space of 2x, integer value I3, then add space 2x, and after that we have a string, then f of, let's keep 4 decimal places, f of 6.4, altogether of 6 characters, then close. Let's see. Now save it and go to compile. 48. For n is equal to 48, integral value is 1. Let's format it. Yeah, in trapezoidal rule, for n is equal to 48, we had integration value 0.99949, and in Simpson 1/3 rule we have 1.0000 followed by 4 zeros. Again we are gonna go with the Simpson 3/8 rule. What we do is we go to zedit Simpson 3/8.f90, and so almost we have similar coding. Now go with Simpson 3/8 rule. Simpson 3/8 rule to find the integral of sine of x a is equal to 0, b is equal to pi/2, and n is equal to provided by the user. Here we just mention the function f of x. F is equal to sine of x, and function, this is internal function, and program is Simpson 3/8. Now mention the implicit variables, implicit non real is a, b, h, sum, f, x, and pi, and we have integer we have n and I. Now pi is 4 star 8 10 1.0. Now a is 0, b is pi by 2 as given by the question. Now we just ask the program to enter the number of intervals. Enter the number of intervals n. After entering, it must be read star comma n. Now h is equal to b minus a by n, and sum is equal to f of a plus f of b. Now we use do loop. Do I is equal to 1 to n, and x is equal to a plus I star h. Now we use if condition. If I by 3 star 3 is exactly equal to I, then sum is equal to sum plus 2 star f of x. Else sum is equal to sum plus 3 star f of x. And if do, then we print the results. Print, let's provide the string, and just first of all, let's not format it. Let's display the result as it is. The integral is comma sum is equal to sum star 3 star h by 8. So we can just write sum over here. This answer will be displayed over here. Then and program Simpson 3/8. Here we have just mentioned the real and integer variables and pi, a, b. Then we ask the program to enter the number of intervals. We enter the intervals. Then h is the difference of b minus a by n. Sum initial, this is f of a plus f of b. Then we use do loop from I from 1 to n. then x is equal to a plus the number of intervals into the width of the interval h. If I by 3 in star 3 is equal to I, this means if the number is divisible by 3, then what we do is the sum, and we just sum the even intervals, else we just here we sum the intervals divisible by 3. We sum the intervals divisible by 3, and that means that the intervals divisible by 3 are, for example, y3, y6, and so on. And similarly, those which are not divisible by 3 is just we multiply it by 3 and add here. And if and do, and we just have ended the if conditional and do looping, then finally this sum is multiplied by 3 by 8 times the size of the interval. So this shows this verifies the naming of Simpson 3 by 8 rule. Then finally we print the integral value is sum and end the program. Let's save it and compile it. Fortran Simpson 38.f90 /a.out. Intervals number, let's keep 48. It's solved 1.02454376. Now to just add the formatting and stuff as done previously, we just format it as we give the inverted comma here, and here we have one string and here value. So what we do is just a 1x and the variable, the values should be written, we want to write in 6 characters, 4 after decimal place, 1 character prior to the decimal, so we just write f6.4 and just close the inverted comma, save it and just recompile it. So 48 here. In this way we have the answer for 48 intervals by 3 by 8 rule. We have 1.0245 by 1 by 3 rule, Simpson 1 by 3 rule, we have 1.0000, and similarly for trapezoidal rule we had for 48 intervals 0.9999. This is how we use Simpson 3 by 8 rule and Simpson 1 by 3 rule to integrate the function sin x within the intervals 0 to pi by 2. Thanks for watching this video. Stay connected for more upcoming videos. Do subscribe to my channel. Bye. See you in next video.